Hello, I'm Daria, and today we're going to talk about soil salinization, where it comes from, why it's so dangerous for the plants, and what to do if it's already happened to your field or in your greenhouse. So let's start with defining some important terms. Soils with an excessive content of water-soluble salts or sodium ions, usually up to 0.25%, are considered to be salinized soils, also known as salt-affected soils. Unfortunately, there are lots of such soils on our planet, and according to Food and Agriculture Organization, up to 25% of all arable land on Earth are salinized soils. In Europe, the most saline soils are found in Hungary, Moldova, southern Ukraine, Spain, and Italy. And world record holders for soil salinity are Asia, South America, and Africa. There are two types of salinization: natural or primary salinization and secondary salinization. So let's start with the first type first. In most cases, natural salinization is directly related to topography. It's quite typical for areas of insufficient moisture, where constant evaporation of groundwater from the soil pulls up salts to the surface. The so-called saline-chucked patches, or even mini salt lakes found in the lowlands, in between of the hills, are typical examples of such natural salinization. Also, high salt content in the parent soil-forming rock itself is another reason for high soil salinity. On this slide, you can see a typical example where salt deposits lie many, many meters deep in famous Wieliczka salt mine in Poland. Obviously, saline soils are not so common in areas of heavy rainfall, but they do occupy a significant area in dry and hot regions, such as steppes in Central Asia. And the last reason for primary salinization is intrusion of salt water into the groundwaters. It occurs because of the physical properties of saline water, which has a higher mineral content than fresh water, meaning it is much more dense, and has higher water pressure. As a result, salt water can push inland beneath the fresh water, as it's shown in this beautiful diagram right here. However, often people create salinized soils with their own hands, which is called secondary salinization. And excessive doses of fertilizers are the first and foremost reason for secondary salinization. Almost all the fertilizers that we use are soluble salts, and if calculated and applied in reasonable doses, then there's no problem. Let's just use them to form its biomass. However, if we introduce fertilizers at inadequately high rates, then a significant part of these fertilizers just remain in the soil solution, increasing the soil salinity. Fertilizers that have, let's call them, ballast components lead to the same problem. For example, potassium salt, which is very popular among farmers, it's just a mixture of two salts, potassium chlorite and sodium chlorite, which is just a table salt. Plants' needs for sodium, are much less than for potassium, and thus sodium chlorite tends to just remain in the soil solution for years. And if conditions for leaching the salts into the lower horizons of the soil do not occur, then salts just accumulate in the soil's arable layer, gradually reducing its fertility. But excess mineral fertilizers are not the only ones that lead to secondary salinization. Excessive organic fertilizers do exactly the same thing. It is especially true for sheep and bird manure because of its chemical composition. Greenhouse farmers face this problem notoriously frequently. For those ones who produce early and expensive vegetables and greens, prices for manure are definitely not a concern, and they often fill their greenhouses with a 10-centimeter layer of, let's say, bird manure, which, of course, leads to secondary salinization. Under no circumstances should organic fertilizers be considered to be safe to use in any dose you want. Their application doses must be carefully calculated based on the soil lab reports and the crop's needs, and even the storage of the manure has to be carefully considered. For example, AgroAnaliz specialists told us about the case of one farmer who was storing sheep manure in piles on the slopes of the hills where his farm was located, and each rainfall would cause streams of brine flow from these piles, just replenishing the salt reserves in the farm and adding to the patches of lifeless salinized soils. On the other hand, properly managed organic matter, such as semi-rotten straw manure or fresh, properly fermented cow manure, these are surprisingly the most effective tools in fighting against salinization. So, the dose makes the poison. Now to water, one of the most important factors in growing any crop, and something that can also lead to secondary salinization if managed poorly. The most dangerous method of irrigation from this point of view is irrigation ditches. However, overhead irrigation can also lead to secondary salinization, and even with drip irrigation systems, improper operation of the system or design errors can also lead to emergence of secondary salinization pockets on the field. Usage of salt water can also be a potential cause for that. Most farmers usually test the quality of their irrigation water before building the system, and that's right. But not all of them know that water salinity can change over the years, and it can change even over the course of one season. If, for example, water is being tested in early spring, then the lab reports would probably show acceptable values for salinity. And there is a very logical explanation for it, because majority of the world regions receive their annual precipitation during winter, when fresh water seeps into the bodies of water from rain and melted snow. But after a particularly dry and hot summer, concentration of the salts will increase in bodies of water because they just become less full. And therefore, it is extremely important to check on your irrigation water quality regularly, even over the course of one season. Another case of secondary salinization is salinization of a substrate when growing seedlings in pots and trays. The basis of such substrate is usually peat, which is very poor in nutrients and therefore has to be compensated with additional fertilizers. Sometimes producers do compensate it with extra fertilizers, and sometimes farmers, not aware of it, add even more fertilizers. And because the pot is so small, it's really easy to overdo the fertilizers and create the salinity problem with our own hands, which either leads to the plant's further developmental problems or to the loss of the seedling from the very beginning. And some of you may say that the peat situation doesn't seem to add up. After all, peat is so water permeable, salts should be easily washed off during watering. And that's right, peat is very water permeable, but there's this one technique subtlety that one should be aware of if they want to create conditions conducive for the salts being washed off. If the peat is too dry, the water won't go through it easily. After the first minutes of watering, it'll seem that there's enough moisture and a familiar puddle will form on the surface of the soil, but the water won't go through the substrate if it's too dry, and we will create an evaporation regime, which, of course, will lead to accumulation of salts. To prevent such a problem, watering must be carried out in several steps. First, the peat has to be moistened, making sure that the water appears in puddles under the pot's drainage holes when the full dose of water is being given. And following these simple steps will protect you from most common problems with growing seedlings and salinity. And lastly, in this photo, you see a scene typical for drip irrigation fields in summertime. Is it also salinization, you might ask? Well, it might be. However, such a whitish film can also be just a salt crust, which forms when water evaporates from the soil surface on a hot, dry day, and the salts dissolved in it just settle in the form of this white, thin film. And if this film is just a few millimeters thick, then there will be no problem for the plants because their roots are located much deeper. But exactly the same whitish spots can also be a sign of salinization. So it's really hard and pretty much impossible to give a definitive answer whether it's salinization or not without the soil lab report. Thank you so much for your attention. Please let us know if you have any questions. Don't hesitate to reach out. Here's our contact information, and I hope you have a great day.